Mhm, mhm, mhm. Hey guys, good evening, and welcome back again to your Unacademy NEET English channel. I hope all of you are doing great, having a good time. So, my dear students, let me know once in the chats if all of you can hear me, if I'm perfectly audible, visible to every one of you. Let me know quickly in the chats. Let me know quickly in the chats if all of you can hear me, if I am perfectly audible and visible to every one of you. Let me know quickly in the chats. Let me know quickly in the chats. Is there any glitch? Why chats are not moving? Just a second. Why the chats are stuck? Let me check it again. I think now it's fine, yeah? There is some glitch though. The chats are not moving fast. There is something wrong. Chalo, let me know in the chats quickly if all of you can hear me, if I'm perfectly audible, visible to every one of you. Good evening, people. Good evening and welcome back. 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 All right, perfect, perfect. So, my dear students, let me tell you, few days back, I posted one video wherein I gave you the top 50 concepts of chemistry. I would say your almost 90% paper in chemistry comes from those topics only, right? So we thought, let's try to cover those 50 topics so that the ones who are looking for the shortcut towards success, let them have the shortcut towards success, yeah? All right. So before starting the session, can you quickly tell me in the chats once which part of the country you guys are watching me from? I just want to know which state you guys are watching me from right now. I just want to know that. Which state you guys are watching me from right now? I just want to know that first. As I can see, Tamil Nadu, Kerala, AP, Kerala, Pondicherry, Maharashtra, Gujarat, Telangana, Goa, okay, Bihar, Kashmir. All right, Dubai. Wow, nice. Himachal, Assam, Mizoram. Okay, Karnataka, Telangana, Kashmir, Bangalore, West Bengal, Mumbai, Maldives. Is that? Calicut, Odisha, and Gujarat, UP, Delhi. Okay, Haryana also. Great. Perfect, 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 perfect. So I can see majority of the students watching me right now are from South India. Great, great, great. And I'm live from Srinagar, Jammu and Kashmir. Yeah? From north to south, then from east to west, everything is covered. So people, again, let me quickly tell you. Few days back, I posted one video wherein I gave you top 50 concepts of chemistry. And Your 90% of the paper every year in the NEET examination in the subject chemistry comes from those topics only. So I thought to discuss those topics with all of you, right? So let me give you the schedule of these 50 topics. Since we have to discuss these 50 topics in detail, that means theory as well as the problems. It's not like I'll be doing some problems and leaving. No, I'll be discussing the theory of these 50 topics as well as the problems of these 50 topics as well. So for that, we have created, just a second, for that, we have created total 1, 2, 3, 4, 5 sessions, right? In every session, 10 concepts will be discussed. Let's say today we have got 10 concepts. I'll be discussing 10 concepts, right? 10 short concepts will be discussed with me. Tomorrow, it's going to be 10 concepts of organic by KK sir, right? Friday, it's going to be again 10 concepts with me. Sunday, it's going to be 10 concepts by KK sir. And then on Tuesday, it's going to be 10 more concepts by me. So total 30 concepts I'll be discussing and 20 concepts your KK sir will be discussing. And KK sir will be basically taking care of your organic, right? I'll be discussing your physical and inorganic in this particular top 50 concept series. Okay? Well, the session duration is not going to be very long. I'll be completing these 10 topics in 2 to 3 hours. So just be with me till the end, right? Because, my dear students, again I'm telling you, your 90% paper of chemistry will be from these 5 sessions, right? Will be from these 50 topics, which we are going to discuss in detail, right? Perfect. Every session will be 2 to 3 hours. Every session. So today's session will be 2 to 3 hours. Similarly, KK sir session will be 2 to 3 hours. All the sessions here will be 2 to 3 hours. Right? So it means in how many hours? If I keep the average as 3 hours here, 3 into 5. In 15 hours, all the 50 concepts of chemistry will be discussed in detail. Right? No, there won't be a single shot of 50. Otherwise, it's going to take 15 hours. 15 hours stretch. I'm not going to do that. That's why I've divided this into 5 parts. Because I want to discuss every single thing in detail. Right? And the ones who have not watched that particular video, that top 50 concepts video, when I gave you those top 50 concepts, go to the video category. The first video is that only. Yes, questions as well as theory is included. So should we start? All ready? Say yes or no quickly in the chats. So this is going to be your session number 1, that is today with me. Already people say yes or no in the chats, everyone. And at the same time, the session PDF of the today's session, the session PDF, the handwritten PDF of the today's session, I shall be sharing on my Telegram channel, which is Wassim Bhat Chemistry Official. Wassim Bhat Chemistry Official is the name of the Telegram channel on which I shall be sharing the handwritten notes of all these 5 marathons. So if you are not the part of the Telegram channel yet, be the part of the Telegram channel as soon as possible. My dear students, I'm telling you, these 5 sessions are super enough, I'm telling you, to score 140 plus in chemistry. Trust me on that. Just be the part of these sessions till the end and watch them completely. Okay? Got it? Got it? Again, I'm telling you, from these total 5 sessions, 140 plus in chemistry is my guarantee, my dear students. Because I've selected those 50 topics from which 90% chemistry paper comes, basically. Okay? So without wasting any sort of time, timing of all these sessions will be 9 p.m. Timing of all these sessions will be 9 p.m. Okay? Chalo, without wasting a lot of time, let's get going. Let's get started, my dear students, with the concept number 1. And concept number 1 is going to be your limiting reagent. Concept number 1 is going to be your limiting reagent. So I'm writing C1 over here. So please take a note of every single thing what I'll be discussing. This is our first concept from which question is going to come for sure. My dear students, this particular concept, limiting reagent, it is from the chapter mole. It is from the chapter mole, your class 11th, first chapter. Okay? Now, what this limiting reagent first of all is, try to understand very carefully what I'll be doing. My dear students, limiting reagent is basically that reactant. Limiting reagent is basically that reactant which gets completely consumed. that reactant which gets completely consumed. What does that mean? What does that mean? Try to understand. For example, people, for example, I am giving you a reaction, a general reaction like this. A plus B, it gives C plus D. This is one general reaction, a balanced chemical equation in which the stoichiometric coefficients of all the reactants and products I am keeping as 1. Stoichiometric coefficient of this is 1, stoichiometric coefficient of this is 1, stoichiometric coefficient of this is 1, and stoichiometric coefficient of this is 1, right? I'm keeping the stoichiometric coefficients of all the reactants products equal to 1. Now, my dear students, first of all, this particular reaction will be taking place definitely in some container. Let's say this is the container in which this particular reaction is going to take place. This is the container in which this particular reaction is going to take place. Now, for example, I am writing time t is equal to 0. What does that mean? Time t is equal to 0 means the reaction has not started. Time t is equal to 0 means the reaction has not started. If the reaction has not started, that means products have not got formed yet. Reaction has not started, that means products have not got formed yet. So I would say at time t is equal to 0, number of moles of product in the container are going to be 0 and 0. Number of moles of C will be 0, number of moles of D will be 0, because at time t is equal to 0, reaction has not started. A and B has not reacted yet. Okay? So what is present at time t is equal to 0? At time t is equal to 0, only and only reactants will be present. Let's assume we have got some 10 moles of A and 5 moles of B present in the container at time t is equal to 0. Okay? Let's say at time t is equal to 0, we have got some 10 moles of A, 5 moles of B. Now, as the reaction starts, number of moles of reactants, they keep on decreasing. As the reaction starts, as these reactants start to react and form products. So, I would say as the reaction starts, number of moles of reactants, they are going to decrease with time. And number of moles of products, they are going to increase with time. They are going to increase with time. Since number of moles of reactants are decreasing with time, so can I say, out of these two reactants, there will be one reactant which would be getting completely consumed? Can I say out of these two reactants, there will be one reactant which would be getting completely consumed? Right? And which one do you think among these two would get completely consumed? I would say B would get completely consumed. So after some time, as the reaction starts, after some time, you'll find 0 moles of B in the container. You'll find 0 moles of B in the container after some time, right? And my dear students, that particular reactant which gets completely consumed, that's what I'll be calling as limiting reagent. So B is my limiting reagent here. B is my limiting reagent here, right? If B is the limiting reagent, A I will be calling as the excessive reagent. A I'll be calling as the excessive reagent. That means out of 10 moles of A, some moles of A would be still present in the container. When B got completely consumed, at that point of time, you'll find some moles of A still present in the container. And at the same time, some moles of C and D would also have got formed. Some moles of C and D would have got formed as well. And this is the time, my dear students, when the reaction would have stopped. This is the time when the reaction would have stopped because B got completely consumed. No doubt there are some moles of A present in the container. But with those some moles of A which are present in the container, there is no B left which could react with those some moles of A. So I would say the reaction would have stopped at that point of time, right? And my dear students, let me tell you, in a chemical reaction, entire product formation, and entire excessive reagent left is decided by what? Is decided by the limiting reagent. So basically, limiting reagent is the one that decides everything. Limiting reagent is the one that decides everything. Perfect. Limiting reagent is the one that decides everything. Limiting reagent is going to decide how much C got formed, how much D got formed, how much A is left. All those things is basically taken care by the limiting reagent. Now, directly without wasting a lot of time, let me show you how this concept is used in the questions. First of all, at time t is equal to 0, there will be only moles of reactants present in the container. Moles of products in the container will be 0. As the reaction starts, moles of reactant will keep on decreasing. Moles of product will keep on increasing. there'll be one reactant which would get completely consumed. You call that reactant as the limiting reagent. Other one is called as the excessive reagent. All the product formation is completely decided by your limiting reagent. Now have a look how exactly. My dear students, this is one simple question in which you just have to identify your limiting reagent. This is your simple question in which you just have to identify the limiting reagent. See how you exactly do that. Try to understand. The reaction that's given to you is 2 times NaOH plus H2SO4. It gives Na2SO4 plus 2 times H2O. This is your reaction. Okay? My dear students, the reaction is already given in the balanced format. The stoichiometric coefficient here is 2. Here it's 1. Here it's 1. And here it's 2. The reaction is already given in the balanced format. Okay? Now, as per the question is concerned, at time t is equal to 0, we are starting with 3 moles of NaOH. And we are starting with 4 moles of H2SO4. Now tell me, at time t is equal to 0, how many moles of product will be there in the container? 0 and 0. Right? I just have to check which one is the limiting reagent among the two. Now, how do we exactly check which one is the limiting reagent? There is one simple trick for that. To check which one is the limiting reagent. What you have to do is, you just have to divide the moles of NaOH with its stoichiometric coefficient. You just have to divide the moles of H2SO4 with its stoichiometric coefficient. This value is coming out to be 1.5. This value is coming out to be 4. Now, which one seems to be lesser value? I would say 1.5 seems to be lesser. That reactant which gets the lesser value, that's always your limiting reagent. So which one is my limiting reagent here? I would say NaOH is my limiting reagent here, which I was supposed to check. Right? Simple. So there will be questions wherein you have to identify which one is the limiting reagent. Divide the given moles of reactants with the respective stoichiometric coefficients. The one that gets the lesser value, that's always your limiting reagent. Perfect. So what is the answer of this question? It's going to be NaOH. And this is the asked question, guys. Okay. Moving on to the next question of the same concept. See, guys. We are given with a balanced chemical equation, and the balanced chemical equation is something like this. 6 times LiH plus 8 times BF3. It gives 6 times LiBF4. 6 times LiBF4 plus B2H6. This is your balanced chemical equation, right? My dear students, it's not necessary that the reaction will be balanced in the question. Sometimes you will be given the question wherein the reaction won't be balanced. You will have to balance the reaction first. If the reaction is not balanced, then you will have to balance the reaction first. Now try to understand. Initially at time t is equal to 0, I'm starting with 2 moles each of reactants. We are starting with 2 moles each of reactants. So this would be 0, this would be 0. Why? Because the reaction has not started yet. Okay. Now, my dear students, what do we have to calculate? We have to check how many moles of B2H6 would have got formed at the end of the reaction. At the end of the reaction, how many moles of B2H6 would have got formed? Now, how do I do it? Your first thing will be to identify the limiting reagent, because the limiting reagent is the one that decides everything. So identify your limiting reagent. How do I identify the limiting reagent? Given moles of reactants divided by their respective stoichiometric coefficients. So 2 divided by 6, right? 2 divided by 8. Which value is coming out to be lesser? 2 by 6 or 2 by 8? This value is lesser. 2 by 8 is lesser, right? Then 2 by 6. If this value is lesser, that means your BF3 is the limiting reagent. If BF3 is the limiting reagent, that means entire product formation will be decided by BF3. Entire product formation will be decided by BF3. Now have a look. The stoichiometric coefficient here is 8. And the stoichiometric coefficient is 1. Perfect. Now what you have to do? In simple terms, what do you have to do? You have to calculate moles of B2H6, right? You have to calculate moles of B2H6. First, write the stoichiometric coefficient of B2H6. Write the stoichiometric coefficient of B2H6 divided by. Write the stoichiometric coefficient of limiting reagent. Write the stoichiometric coefficient of limiting reagent. Multiply with the moles of BF3. Multiply with the moles of limiting reagent. Got it? Stoichiometric coefficient of product divided by stoichiometric coefficient of limiting reagent multiplied by moles of limiting reagent. So let me write it. Stoichiometric coefficient of what you have to calculate divided by stoichiometric coefficient of limiting reagent multiplied by number of moles of limiting reagent. Number of moles of limiting reagent. Simple. Simple. So these are basically the number of moles of B2H6 which would have got formed at the end of the reaction. So the value is 2 by 8, 1 by 4, 1 by 4 is 0.25. So I would say 0.25 moles of B2H6 would have got formed at the end of the reaction. Got it? Clear? Simple. One more question. One more question. Again, this is the asked question. Again, this is the asked question. The reaction is given and you are going to solve this question on your own right now. Give it a try right now. You are given the reaction 3 times BaCl2 plus 2 times Na3PO4. It gives Ba3PO4 whole twice plus 6 times NaCl. This is your reaction. Now on starting with 10 moles each. So at time t is equal to 0, we have got 10 moles of this. Again, we have got 10 moles of this. So this would be 0, this would be 0 because the reaction has not started yet. Now tell me which one is the limiting reagent, quickly. You tell me in the chats. Which one is the limiting reagent? Quick, 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 quick. Given moles divided by respective stoichiometric coefficients. 10 by 3, 10 by 2. 10 by 3 is 3.33. 10 by 2 is 5. Which one is having the lesser value? 10 by 2 or 10 by 3? 10 by 3 is lesser. So this is your limiting reagent. So entire product formation is decided by the limiting reagent. Now what do we have to calculate? We have to calculate the moles of barium phosphate formed. How many moles of barium phosphate have got formed? What do you have to do? I would say moles of this barium phosphate will be equal to stoichiometric coefficient of this, which we have to calculate, divided by stoichiometric coefficient of the limiting reagent multiplied by number of moles of limiting reagent. So 10 by 3 is equal to 3.33. So these are the moles of barium phosphate which would have got formed at the end of the reaction. Simple. Done and dusted. Can you... Okay, this is done. Right? This is done. Asha, by the way, one more thing I have to tell you here. What is that? Sometimes in the question, they won't be giving you directly with the moles. They might give you the mass. They might give you the mass. Or they might give you the volume. Your first step would be to convert those given quantities into moles. To convert those given quantities into moles. Perfect? Sometimes they will give you the mass of the reactants. At that time, what do you have to do? Given mass divided by molar mass. That gives you moles. Right? Sometimes they'll give you volume of the reactants. Given volume divided by 22.4. That will give you the moles of the reactants at STP. Right? Yes? Am I clear with this? Am I clear with this? Everyone in the chats? Sir, you don't know Hindi. Beta, this is the English channel. In English channel, you are supposed to speak in English. Hindi channel hoti to Hindi mein baat karta. Okay? So I believe this particular concept is clear. Is it? Can you tell me how many moles of NaCl would have got formed? Quickly. Moles of NaCl. How many moles of NaCl would have got formed? Stoichiometric coefficient of NaCl divided by stoichiometric coefficient of limiting reagent multiplied by number of moles of limiting reagent. Right? Done? So I would say 20 moles of NaCl would have got formed. Perfect. Similarly, if I ask you how many moles of excessive reagent would be left in the container? How many moles of excessive reagent would be left in the container? So first of all, I'll see how many moles of Na3PO4. See, first of all, Na3PO4, it reacts with BaCl2. It reacts with BaCl2. So I'll first of all check how many moles of Na3PO4 have reacted. Have reacted. How do I check that? Stoichiometric coefficient of Na3PO4 divided by stoichiometric coefficient of your limiting reagent multiplied by number of moles of the limiting reagent. So it's 20 by 3, 6.66. So these are the moles of Na3PO4 that have reacted. How many I took in the beginning? 10. Out of 10, how many are reacted? 6.66. So how many are left? 10 minus 6.66. It will be 3.33. So 3.33 moles of Na3PO4 would be still left in the container. And since this is the limiting reagent, it would have got completely consumed. So I believe this particular concept is clear to everyone. Okay? So anything can be asked out here. Okay? Perfect. Let me move on to concept number 2. My dear students, concept number 2 is again important concept and easy. What is that? It is your empirical and molecular formula. Empirical and molecular formula. So I'm writing here, I'm mentioning here concept number 2. Your empirical and molecular formula. Your empirical and molecular formula. Now let's have a look what this empirical and molecular formula exactly is all about. Have a look, guys. First of all, two things, guys. For example, if I write glucose here, if I write glucose, I'm writing glucose. Do you know any of the formulas of glucose? Do you know any? Glucose. You would be knowing it, right? C6H12O6. This is your glucose. How many elements do you see here? 3 elements. Carbon, hydrogen, oxygen. Carbon, hydrogen, oxygen. Right? Now, first of all, what is the atomic ratio here? It is 6:12:6. The atomic ratio is 6:12:6. Tell me one thing. Can you further simplify this ratio? Absolutely, you can further simplify this ratio. It would come as 1:2:1. It would come as 1:2:1. Now, my dear students, tell me how many ratios do you see? We have got 2 ratios. This particular ratio is the simplest whole number ratio. It is the simplest whole number ratio. Simplest whole number ratio. And this particular ratio I'll be calling as actual ratio. This particular ratio I'll be calling as actual ratio. As per the actual ratio, the formula is C6H12O6. As per the simplest ratio, the formula should be C1H2O1. There are 2 ratios. Actual ratio, simplest whole number ratio. As per the actual ratio, formula has to be C6H12O6. As per the simplest ratio, the formula has to be C1H2O1. That particular formula which gives me the simplest ratio, you call that formula as the empirical formula. And that particular formula which gives me the actual ratio, you call that particular formula as the molecular formula. So there are 2 formulas. There are 2 representations. One is empirical formula, one is molecular formula. Empirical formula gives us simplest whole number ratio. Molecular formula gives us the actual ratio. Correct? Correct? Now, try to understand one more thing. My dear students, with the help of molecular formula, we can calculate molecular mass. And with the help of empirical formula, you can calculate empirical mass. With the help of molecular formula, you can calculate molecular mass. With the help of empirical formula, you can calculate empirical mass. How exactly? Molecular mass will be equal to. Molecular mass will be equal to sum of these atomic masses. Tell me what is the atomic mass of carbon? That's 12. How many carbon atoms? 6. Plus, what is the atomic mass of hydrogen? 1. How many hydrogen atoms? 12. Plus, atomic mass of oxygen, that is 16. How many oxygen atoms? 6. The value comes out to be 180 AMU or 180 U you can write. This is your molecular mass, right? Similarly, use the empirical formula and calculate the empirical mass. It's going to be, in order to calculate empirical mass, you need empirical formula. Have a look. This is your empirical formula. What is the atomic mass of carbon? 12 multiplied by only 1 carbon atom plus atomic mass of hydrogen, that's 1 multiplied by 2 hydrogen atoms. Similarly, atomic mass of oxygen, that is 16 multiplied by 1 oxygen atom. When you calculate, the value comes out to be 30 AMU or you can say 30 U. So, with the help of molecular formula, you calculate molecular mass. With the help of empirical formula, you calculate empirical mass. Now, let me tell you one very, very, very important thing. Let me tell you one very, very, very important thing. What is that? My dear students, I am defining a number which I represent with X. I'm going to define a number which I represent with X. And what this X is? X is nothing. It is molecular mass divided by empirical mass. X is nothing. That is molecular mass divided by empirical mass. Okay? X is nothing. Molecular mass divided by empirical mass. And remember one formula. What is that? Molecular formula is always equal to empirical formula multiplied by X. Do remember these 2 things. Do remember these 2 things. Okay? Now, people, let's try to see how we are going to frame questions out of this. Let's exactly see how we are going to frame questions out of this. First of all, tell me once in the chats, did you get all these things? Did you get all these things? Achha, one more thing which I need to tell you here. Sometimes in the question, they won't give you molecular mass. Sometimes in the question, they won't give you the molecular mass. They will give you vapor density. Vapor density of the compound is 30. Vapor density of the compound is 40. Vapor density of the compound is 50. Something like that. Remember, your molecular mass is nothing. Molecular mass is equal to 2 times vapor density. Remember this as well. Now see how exactly I'm going to deal with such kind of the questions which are based on empirical and molecular formula. Try to understand very properly what I'll be doing. The simplest question, my dear students, with which I'll be starting. The simplest question. The simplest question. The simplest question. Have a look. Have a look. Calculate the empirical formula of the compound that contains 26.6% potassium, 35.4% chromium, 38.1% oxygen. Look how exactly I'm going to do it. As per the question is concerned, we are given with a compound and that compound contains certain elements. We have got a compound which contains certain elements. Which all elements? It contains potassium, it contains chromium, it contains oxygen. First of all, atomic mass of potassium is 39, atomic mass of chromium is 52, atomic mass of oxygen is 16. This is something which you should know. This is something which you should know. My dear students, remember one thing. Remember one thing. What is that? In the question, either you will be given with the mass percentage of these elements. As you can see in the question, the mass percentage of the elements is given. Either you will be given with the mass percentage in the question, or you will be given with the mass, or you will be given with the masses of these elements directly. Like you will be given a compound contains 2 grams of potassium, a compound contains 5 grams of chromium, like that. Or you will be given with the mass ratio of these elements. Out of these 3 things, anything can be given. Let me write them like this. Potassium I'll write here. Then chromium I'm writing here. Then oxygen I'm writing here. So first of all, let me repeat again what I'm trying to say. In the question, you are given with a compound. You are given with a compound. Compound contains 3 elements: potassium, chromium, oxygen. Now I'm telling you, in the question, you will be either given with mass percentage or the masses or the mass ratio of these elements. Okay? Out of these three things, anything can be given. Now, my dear students, what you have to do? Have a look exactly what you have to do. Try to understand. In this particular question, what is the mass percentage of potassium that's given to me? That is 26.6%. Mass percentage of chromium is given to me as, there's a reflection here, 35.4. Okay, 35.4%. Right? Mass percentage of oxygen is given to me as 38.1%. Right? The first thing which you have to do, what is that? You have to calculate the atomic ratio. You have to calculate the atomic ratio. And how do we calculate the atomic ratio? How do I calculate the atomic ratio? How do I calculate the atomic ratio? Whatever terms are given to us, be it the mass percentage, be it the masses, be it the mass ratio, divide all these terms by their respective atomic masses. So 26.6 divided by 39. 26.6 divided by 39. 35.4 divided by 52. Similarly, 38.1 divided by 16. Right? In order to calculate the atomic ratio, what you have to do is, whatever quantities are given to you, just divide them with what? Divide them with the respective atomic weights. Okay? Now, when you calculate these terms, this particular term, when you calculate, it will come out to be 0.68. Even this particular term also will come out to be 0.68. And this particular term over here, it will come out to be 2.38. It will come out to be 2.38 when you calculate them. Now, my dear students, after calculating the atomic ratio, now you have to calculate the least atomic ratio. And how do we calculate the least atomic ratio? Tell me which one is the least number among all these three. The least number among these three is 0.68. So divide all these 3 terms with that least number. Divide all these 3 terms with that 0.68. So I'll say 0.68 divided by 0.68. Similarly, 0.68 divided by 0.68. Similarly, 2.38 divided by 0.68. When you calculate, this value is 1, this value is 1, and this value is 3.5. Okay. Now, people, tell me one thing. The least atomic ratio we got as 1:1:3.5. So basically, we are given with elements potassium, chromium, and oxygen. And I got the least atomic ratio as 1:1:3.5. If I ask you, is this the simplest ratio? I mean, is this the whole number ratio? Do you see 3.5 here? It is not the whole number ratio. What do we need? We need the simplest whole number ratio. It is not the whole number ratio. So convert it into whole number ratio. How? Multiply this with 2, multiply with this with 2, multiply this with 2. The value comes out to be 2 is to 2 is to 7. So this is the simplest whole number ratio over here. So as per the simplest whole number ratio, what should be the formula? It should be K2 Cr2O7. I would say this particular formula is giving me the simplest whole number ratio, and I'll be calling this particular formula as the empirical formula, my dear students. If you got it, let me know once in the chats. Let me know once in the chats. Quickly in the chats. Done? Let me show you one more question. With that, things will be more clear. Have a look, people. Have a look. Have a look. A compound of nitrogen and oxygen. You have got a compound. This compound contains which all elements? This compound contains nitrogen and oxygen. The compound contains nitrogen and oxygen. And in this question, I'm given with mass ratio 7:16. I'm given with mass ratio of these two elements, which is 7:16. Right? What is the atomic mass of nitrogen? 14. This is 16. What is my first step always? Calculation of atomic ratio. How do I calculate atomic ratio? Given terms divided by the respective atomic masses. So 7 divided by 14. Similarly, 16 divided by 16. This value is equal to 0.5. This value is equal to 1. Now, which one is the least term among the two? It's 0.5. So divide both of them by the least number. You'll be getting the least atomic ratio. So it's 0.5 by 0.5. That's 1. 1 divided by 0.5. That's 2. So your least atomic ratio came out to be 1:2. So I would say your empirical formula would be, it would be N1O2. N1O2. This is your empirical formula. But in the question, are we supposed to calculate empirical formula? No. I'm supposed to calculate molecular formula. I am supposed to calculate molecular formula. Remember, my dear students, if you remember few minutes back only, I gave you one formula. Molecular formula is equal to empirical formula multiplied by X. Empirical formula I got. What do I need? I just need X. What is X exactly? X is the ratio of molecular mass to that of empirical mass. Right? Is molecular mass given? No. Vapor density is given. How much? 46. I told you a few minutes back only. Molecular mass is equal to 2 times vapor density. Molecular mass is equal to 2 times vapor density. So 2 into 46, that is 92. Divided by empirical mass. I'll be calculating with the help of empirical formula. Empirical mass, I'll be calculating with the help of empirical formula. 14 into 1. 14 into 1 plus 16 into 2. This value again will come out to be 46. So divide with 46, the value comes out to be 2. So you got the X. So molecular formula will be empirical formula N1O2 multiplied by X. X value is 2. So it's going to be N2O4. So N2O4 is the molecular formula of the compound. If I'm clear with this particular concept as well, let me know once in the chats quickly. Tell me quickly in the chats. Quick, people. Say it in the chats, yes or no, quickly. I want everyone to say it. Guys, I'm starting all the things from zero. And I'm just telling you those things which are required to solve the questions. Nothing more, nothing less. Not going into very detail, right? Okay? Just I'm giving you those sort of concepts which are required to do the questions based on these concepts. Right? Where did 92 come from? I gave you the formula a few minutes back. Molecular mass is equal to 2 times vapor density. Vapor density is given 46. So molecular mass is 2 times 46. That comes out to be 92. Okay. One question I'll be giving you as the homework. You are going to do that question on your own. And do let me know its answer in the comment section. At the end of the session, once the session ends, this is your homework question of the same pattern. Do check it out. Okay. Do check it out. Do give it a try and tell me, write its answer in the comment section. So this was our concept number 2. Now people, I'm going to move on to the concept number 3. I'm going to move on to the concept number 3. What is the concept number 3? Just a second. I'm going to move on to the concept number 3. Concept number 3 is from the chapter atomic structure. Concept number 3 is from the chapter atomic structure. And what is that? That's basically the concept from your Bohr's model. What exactly? I would say questions based on radius, velocity, and time period. Questions based on radius, velocity, and time period. Look exactly what I'll be doing. Out of these 3 things, anything can be asked in the question, guys. Out of these 3 things, anything can be asked. Now, let's first of all get to know what exactly it's all about. So, my first concept here is that is how do we calculate the radius of nth Bohr's orbit? What does that mean? Let's have a look. Radius of nth Bohr's orbit, which I represent with Rn. What exactly is meant by that? See, guys, have a look. See, guys. For example, I am going to take an atom. This is its nucleus. I'm basically taking a single electron species. I'm taking that species which just contains 1 electron. Bohr's model is valid for single electron species. Okay? Bohr's model is valid for single electron species. Those species which contain only 1 electron. So let me take, for example, an atom like this. This is the nucleus of the atom. And this is, for example, some shell which I represent as nth shell. This is the shell in which electron is revolving. This is your electron. Right? I am taking an atom whose nucleus is this, and this is the shell which I call as the nth shell in which the electron is revolving. Okay? Now, my dear students, let's assume that atomic number of this atom is equal to Z. Z represents atomic number of the element. Z represents atomic number. For example, I have to calculate the distance from here to here. You call this distance as the radius of the nth Bohr's orbit. I have to calculate the radius of this Bohr's orbit in which electron is revolving. I have to calculate this radius. How do we calculate this radius? There's a simple formula for that. What is that? Radius of nth Bohr's orbit is given by the formula R0 n square divided by Z. Radius of nth Bohr's orbit is given by the formula R0 n square divided by Z. Let me tell you, this R0 is a constant whose value is 0.529 angstroms. 0.529 angstroms. This n is the shell number in which electron is revolving. 1, 2, 3, 4. This Z is the atomic number. This is formula number 1. Formula number 2. For example, you have to compare the radii of 2 Bohr's orbits. Let's say you have to compare the radii of 2 Bohr's orbits. What you'll be doing? You'll be writing R1 divided by R2 is equal to N1 square divided by N2 square multiplied by Z2 divided by Z1. Just remember this formula for now. I'll show you its application part in some time. Okay. The radius of the nth Bohr's orbit is given by the formula R0 n square by Z. N is nothing but the shell number in which electron is revolving. Z is the atomic number. When you have to compare the radii of 2 Bohr's orbit, it's going to be R1 divided by R2 is equal to N1 square divided by N2 square into Z2 divided by Z1. I believe till here it's clear. Now, guys, before showing you its application part, there are a few more things which I need to tell you. What is that? What is that? Graphs. For example, if Z is kept constant, for example, Z is kept constant, okay? And I have to plot a graph between radius of nth Bohr's orbit versus n square. One more graph. If z is kept constant, I have to plot a graph between radius of nth Bohr's orbit with n. What would be the nature of these two graphs? What would be the nature of these two graphs? Have a look. Your formula is Rn is equal to R naught n square divided by z, right? R naught n square divided by z. So your radius of nth Bohr's orbit is equal to R naught n square divided by z. Now, z is already kept constant. This is constant, this is constant. So division of these two constants, since this is constant, this is constant. Division of these two constants is one more constant. Let me call this constant here as k, right? Now, if you look at this particular graph, Rn, radius of nth Bohr's orbit, you're plotting along y-axis. This you're plotting along y-axis. N square, you're plotting along x-axis. Instead of n square, you're plotting along x-axis. K is going to be your m. Y is equal to mx. What is the nature of the curve for y is equal to mx? Y is equal to mx means straight line passing through origin. Straight line passing through origin, right? And if I ask you, what would be its slope? Slope is basically the value of m. M is what? M is k. And k was what? K was R naught divided by z. Correct? Simple. The second graph, radius of nth Bohr's orbit versus n. Radius of nth Bohr's orbit versus n. Now, radius of nth Bohr's orbit you are plotting along y-axis, right? Now, n you are plotting along x-axis, not n square. This is n. So, instead of n, you are going to write x. So, this n ka square, so x ka square. Y is equal to kx square. Y is equal to kx square. It's going to be parabola opening upwards. It's going to be parabola opening upwards. So, these are the two graphs which you have to remember here. These are the two graphs which you have to remember here, right? At the same time, these two graphs I made when I kept z constant. When I kept z constant. Now, few more graphs I can plot here. What are going to be the graphs? Just a second. What are going to be the graphs? Have a look. Have a look. Few more graphs I can plot here. My dear students, now the second case, I can keep n constant as well. I can keep n constant as well. I can keep n constant as well. If n is constant, that means n square automatically becomes constant. And I want to plot a graph between R and z. So, I want to plot a graph between radius of nth Bohr's orbit versus z. So, tell me one thing. Radius of nth Bohr's orbit and z, are they directly or inversely proportional? They are inversely proportional. They are inversely proportional. And whenever you have to plot a graph between two variables which are inversely proportional, whenever you have to plot a graph between two variables which are inversely proportional, the nature of the graph is something like this. And you call the graph as the rectangular hyperbola. You call the graph as the rectangular hyperbola. Am I clear with this? Am I clear with this, people? So this is something which you have to remember. Okay? This is something which you have to remember. So in this particular concept number 3, this was the first sub-concept. I'll show you its questions in some time. Just wait for it. In the third concept, this is the first sub-concept. Now, second sub-concept. What is that? What is that? What is that? That is, the second sub-concept here is the velocity of the electron in the nth Bohr's orbit. In the nth Bohr's orbit, the velocity of electron in the nth Bohr's orbit, we represent it with Vn. We represent it with Vn, velocity of electron in the nth Bohr's orbit. Okay? Velocity of electron in the nth Bohr's orbit. Do you know the formula? Tell me. The formula is going to be velocity of electron in the nth Bohr's orbit is equal to V naught Z divided by N, where Z is the atomic number, N is the shell number in which electron revolves, right? Now, what is V naught here? V naught is again a constant. V naught is again a constant. 2.18 into 10 raised power 6 meter per second. This is V naught. This is your first formula. Second formula. Whenever you have to compare the velocities of two electrons in two different Bohr's orbits, velocity of electrons in two different Bohr's orbits, what you'll be doing? You'll be writing V1 divided by V2 is equal to Z1 divided by Z2 multiplied by N2 divided by N1. This is the formula to compare that. Now, what about the graphs? Can you make the graphs here? If I talk about the graphs, the first one, I'll keep Z constant, for example. I'll keep Z constant. If I'm keeping Z constant, and I want to plot a graph between velocity of electron in the nth Bohr's orbit versus N. Vn versus N. Inversely proportional, it's going to be rectangular hyperbola, right? Now, if I keep N constant, if I keep n constant, I'm keeping n constant. If I keep n constant and I want to plot a graph between V and Z, I want to plot a graph between V and Z, what it would be? V and Z. V and Z. See, your Vn is equal to V naught Z divided by n. Perfect. V naught is constant. Now you are keeping n constant as well. So this entire term is constant. Velocity of electron in the nth Bohr's orbit you are plotting along y-axis. Z you are plotting along x-axis. Z you are plotting along x-axis, right? So this term becomes your m. Y is equal to mx will be straight line passing through origin. Straight line passing through origin. Its slope will be equal to m, and m value here is nothing but that is V naught divided by n. Got it? Nothing more, nothing less. Nothing more, nothing less. Am I clear to you? Everyone in the chats? Everyone in the chats? Quickly, people. Is it clear? Now, what is the third sub-concept here? What is the third sub-concept here? That is the time period. That is the time period. Third sub-concept. Time period of the electron. Time period of the electron in the nth Bohr's orbit. Time period of the electron in the nth Bohr's orbit. Now, first of all, what is time period? How do we define the time period? Time period is nothing but it is the time taken by the electron to complete one revolution. Time taken by the electron. Time taken by the electron to complete one revolution. Now we will have a look. The formula, direct formula I'm giving you. Time taken by the electron in the nth Bohr's orbit is equal to T naught n cube divided by z square. T naught n cube divided by z square. Okay? T naught n cube divided by z square. What is the value of T naught? T naught value would be equal to 1.5 into 10 raised power minus 16 seconds. This is the value of T naught. This is your first formula. Second formula is simply going to be comparison of time periods. T1 divided by T2 is equal to n1 cube divided by n2 cube multiplied by z2 square divided by z1 square. Right? So my dear students, these are the three sub-concepts under the banner concept number 3. Now, let me show you what kind of questions are asked from this particular topic. Let me show you what kind of questions are asked. See, there I have mentioned derivations as well, but you have got nothing to do with the derivations. Just remove the direct formulas. That's it. Okay? So first of all, this is your first question. Can you give it a try? Can you give it a try? Look at it carefully. Calculate the radius ratio of the second orbit of He positive and third orbit of Be tri positive. So you are given two species. One is your He positive. One is your He positive and one is your Be tri positive. Okay. Let me call this as, okay, let me not call this anything. Let me not call this anything. Now guys say, first of all, what is the atomic number of helium? Hydrogen helium. That is 2. Atomic number is 2. Calculate the radius ratio of second orbit. Here the orbit number is given as 2. Here the orbit number is given 2. Let the radius of this second orbit of He positive is equal to R1. Okay. Here we are given a third orbit. First of all, what is the atomic number of beryllium? Hydrogen, helium, lithium, beryllium. 4. Orbit number 3. Let its radius be R2. What do you have to calculate? We have to calculate the radius ratio. We have to calculate the radius ratio. Ratio of the radii. So basically, we have to calculate R1 divided by R2. I gave you the formula for us back. It's going to be N1 square divided by N2 square multiplied by Z2 divided by Z1. What is N1 square? 2 ka square is 4 divided by N2 square. 3 ka square is 9. Z2. Z2 value is what? 4. Z1. What is Z1? That's 2. Done. 2, 1. Did I take the right values? N1 square. Wait. N1 square. N1 is 2. 2 ka square is 4. N2 square. 3 ka square is 9. Right? Z2. Z2 is 4. Z1. Z1 is 2. Yes, I took the right values. So 2, 1, 2, 2. So it's going to be 4 to 8. 8 is to 9 is the radius ratio which you were supposed to calculate. Yes? Perfect. Now guys, can you give this question a try? Quick on your own. Can you give this question a try? Quickly, guys, you should be in a position to solve this as well. What is it? If the velocity of electron in the first orbit of hydrogen atom, so on one side you are given with hydrogen atom, on the other side you are given with Li dye positive. First of all, tell me their atomic number. Hydrogen, atomic number is 1. Lithium, hydrogen, helium, lithium, atomic number is 3. Okay. If the velocity of electron in the first orbit, N1 value is 1. If the velocity of electron in the first orbit of hydrogen atom is V, so V1 value is V, right? What will be the velocity of electron in the third orbit? N2 value is 3, right? We have to calculate V2. We have to calculate V2. What is the formula that I gave you 2 minutes back? Formula that I gave you was V1 divided by V2 is equal. It is V0 Z by N, right? V0 Z by N. So it is Z1 divided by Z2 multiplied by N2 divided by N1. What is V1? V1 is given as V. What is V2? Needs to be calculated. Z1 value is 1. Z2 is 3. N2 is nothing but 3. N1 is 1. So 3 got cancelled. So the value comes out V1 is to 1. So I would say V is equal to V2. Cross multiple. V2 is equal to V. This is something I was supposed to calculate. Done and dusted. Right? So till now, similarly, a question will be asked from the comparison of time periods as well. And which formula you have to use? T1 by T2 is equal to N1 cube divided by N2 cube. Z2 square divided by Z1 square. Right? Perfect, guys? Perfect. So till now, we are done with 3 concepts. Now the concept number 4. Concept number 4. This is simple, easy, and at the same time, it is less time taking as well. What is that? That is calculation of nodes. Calculation of nodes. This is the direct question that's asked. Calculation of nodes. My dear students, I'm just giving you 3 formulas. Just remember them. And accordingly, you can calculate anything. Accordingly, you can calculate anything. First of all, total number of nodes in an orbit. Total number of nodes in an orbit is given by the formula n minus 1. What is n? N is the principal quantum number. N is the principal quantum number. N is the principal quantum number. Now, these nodes are basically of 2 types. These nodes are basically of 2 types. One is called as spherical, or you call them as the radial nodes. Second category of the nodes is your angular nodes. Your angular nodes. Angular nodes is equal to the value of L, where L is called as the azimuthal quantum number. Where L is called as the azimuthal quantum number. Spherical nodes is nothing but it is n minus L minus 1. N minus L minus 1. So these are first of all the 3 formulas which you have to remember. Now, one by one, I'll be giving you the examples and it will make things clear to you. Much simple. For example, I am talking about 1s. Calculate total number of nodes, angular nodes and radial nodes in 1s. First of all, my dear students, remember for S sub shell, the value of L is 0. For S sub shell, the value of L is 0. For P sub shell, the value of L is 1. For D sub shell, the value of L is 2. For F sub shell, the value of L is 3. Okay. Now, what is the N value here? N value is equal to 1. What is the L value for S? L value for S is 0. Take it out. So, first of all, how many total number of nodes will be there? Total nodes will be equal to total number of nodes. N minus 1. So, 1 minus 1, 0. So, there is 0 node. There are no nodes. Right? I'm talking about 1s. For example, you have got 2s. What is the N value? N value is 2. What is the L value? L value for S is 0. So, total number of nodes. N minus 1. 2 minus 1 is 1. Right? Spherical nodes. Spherical nodes. Spherical nodes. N minus L minus 1. N is 2. L is 0. Minus 1. So, 1 spherical node. Angular nodes is equal to the value of L. L value here is 0. Right? Since there is 1 node and that node is spherical. So, no angular node. For example, you have got 3p. You have got 3p. What is the value of N? N value is 3. What is the value of L for P? L value for P is 1. So, total number of nodes. N minus 1. 3 minus 1 is 2. Right? Spherical nodes. Spherical nodes. N minus L minus 1. So, it comes out to be 1. Angular nodes is equal to the value of L. L value is 1. Done? For example, I'm giving you 4f. What is the N value? N value is 4. For F subshell, SPDF. For F, L value is 3. For F, L value is 3. Right? Right, guys? Now tell me, total number of nodes. N minus 1. 4 minus 1, that is 3. Spherical nodes. n minus L minus 1, right? N minus L minus 1. Tell me how many spherical nodes. Quick. Guys, this is something which you should be doing on your own now. It is 0, right? Angular nodes is equal to the value of L. L value is 3. Done. Question. Direct question is asked from all this. Direct question is asked from all this. Direct question is asked from all this. Okay. Again, one more direct question. Again, one more direct question. Concept number 5. Again, very simple only. Concept number 5. Again, very simple only. What is that? That is orbital angular momentum. They'll ask you. And these are frequently asked questions. Calculate the orbital angular momentum. Have you read the formula to calculate orbital angular momentum? Tell me once in the chats, quick. Quick, people in the chats. What is the formula? I'm asking you. As the formula is pretty much simple. It's under root of L into L plus 1 into h upon 2 pi. This is the formula to calculate orbital angular momentum. Nothing more, nothing less. So, already I have told you for S subshell the value of L is 0. For P subshell the value of L is 1. For D subshell the value of L is 2. For F subshell the value of L is 3. Now, they'll ask you direct questions. Tell me in 1s. Tell me in 2s. Tell me in 3s. Tell me in 4s. What is the orbital angular momentum? Now, you know, for all the S subshells, L value is 0. If L value is 0, this entire term becomes 0. So, for 1s, 2s, 3s, 4s, 5s, 6s, 7s, whatever s, right? Orbital angular momentum is 0, right? Perfect? Perfect, people? Now, for example, they give a question. Calculate the orbital angular momentum in 2p. Now, here's a p subshell. For p subshell, what is the value of L? L value is 1. For p subshell, the value of L is 1. Now, orbital angular momentum formula, what is that? That's under root of L into L plus 1 multiplied by h upon 2 pi. So, it's going to be root of 2. It's going to be root of 2 into h upon 2 pi, right? So, it can be written as h upon root of 2 pi. This is the formula. For example, they'll ask the question, calculate the orbital angular momentum in 3D. In case of D, what is the value of L? L value is 2. So, orbital angular momentum is equal to under root of L into L plus 1 h upon 2 pi. So, 2 plus 1, 3. 3 2s are 6. So, root of 6 h upon 2 pi. Similarly, you can calculate orbital angular momentum of anything. This is again frequently asked question. This is again a frequently asked question, people. Okay, again a frequently asked question. Yeah? Done with this? Now, in your syllabus, there is one concept mentioned. In your syllabus, there is one concept mentioned. What is that? Psi versus R and psi square versus R. Psi versus R and psi square versus R for 1s and 2s. Like this is mentioned in your syllabus. No need to study no need to study P, D, etc., etc. Just 1s and 2s you have to study. And you just have to remember 2 graphs. That's all. That's all. See, guys, I'm going to make these graphs for you so that you can remember them directly. So, for example, I'm making psi versus R for 1s, right? Whenever you'll have to make a graph between psi versus R for s, the graph comes from the top. So, the graph is like this. This is psi versus R for 1s. Remember, they'll ask you psi square versus R. Psi square versus R. It is the same. It is the same. Psi square versus R for 1s. For 1s. Okay. Now, they have mentioned it for 2s as well. in the syllabus for 2s as well. So if I talk about psi versus r for 2s, the graph is something like this. From the top it starts, comes like this. Now psi square versus r for the same 2s. This in your syllabus, psi square versus r. See, from here to here, it is the same. From here to here, it is the same. Now, remove this part, or I would say, take its reflection along this axis. It's going to come like this. Okay? This is your psi square versus r for 2s. These are two more things. I mean, these are 4 graphs. Out of these 4 graphs, anything can be asked. They have not mentioned in the syllabus about 2p, 3p, 4p. Otherwise, I used to teach 2p, 4p, 3p, and in detailed manner. But you can just remember these 4 graphs directly. Okay? Am I clear? Am I clear, people? Am I clear? How many concepts are done so far? Tell me. How many concepts are done so far? Quick. Six. I think I did not give you 50 concepts. I think I gave you 60 concepts. So technically we have to discuss 60 concepts. Technically we have to discuss 60 concepts in total. Okay? All right. So this was your concept number 6. Now comes your concept number 7. Again from the atomic structure only. Concept number 7. Again from the atomic structure. What is that? That is, there are few things which I have to discuss here. That's your hydrogen spectrum. That's your hydrogen spectrum. Let me write the general heading as hydrogen spectrum. And in hydrogen spectrum, what do we have to discuss? Have a look. There are few things which can be asked in hydrogen spectrum. See guys, try to understand very properly what I'll be doing. Try to understand very properly what I'll be doing. Imagine this. It might take some time to make me the diagram. Imagine this is your n is equal to 1. You call it as a ground state. Ground state of hydrogen. Okay. This is your n is equal to 2. This is your n is equal to 2. This is the second shell of second energy state, or you can call it as the first excited state. You can call it as the first excited state. Similarly, imagine this is your n is equal to 3. Imagine this is your n is equal to 3. This is your second excited state. Second excited state. This is, for example, your n is equal to 4. N is equal to 4. This is your third excited state. Okay? Third excited state. N is equal to 5. N is equal to 5. Fourth excited state. One more. N is equal to 6. Fifth excited state. N is equal to infinity. N is equal to infinity. Okay? So this is first of all which I made over here. So I'm talking about which atom? I'm talking about hydrogen atom. Now guys, have you studied one thing? When the electron makes a transition from higher energy state to lower energy state. When the electron makes a transition from higher energy state to lower energy state, it emits energy in the form of radiation. It emits energy in the form of radiation. Right? It emits energy in the form of radiation. Perfect. Now, first of all, when the electron makes a transition from higher energy state to shell number 1. When the electron makes a transition from higher energy states to shell number 1, like this. When the electron makes a transition from higher energy states to shell number 1. 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 When the electron makes a transition from higher energy state to shell number 1, we get a series of radiations. We get a series of radiations. When the electron makes a transition from higher energy state to shell number 1, right? We get a series of radiation. For example, infinity to 1 radiation, this to this, one more radiation, one more radiation, one more radiation. And every radiation is called as a spectral line. Every radiation is called as the spectral line. You can remember it like this. You can remember it like this. And my dear students, this particular series, the series of radiations which we get when the electron makes a transition from higher energy state to shell number 1, the series of spectral lines, right? You call that series as the Lyman series. You call that series as the Lyman series. Similarly, my dear students, similarly, when the electron makes a transition from higher energy state to shell number 2, higher energy state to shell number 2, higher energy state to shell number 2, this series of lines we call as the Balmer series. Higher energy state to shell number 3, higher energy state to shell number 3, you call this particular series as the Paschen series. Higher energy state to shell number 4, this called as, sorry, what did I make? Higher energy state to shell number 4, you call this as bracket series. Lyman, Balmer, Paschen, bracket. Now, higher energy state to shell number 5, Fund series. Similarly, higher energy state to shell number 6, Humphrey series. Humphrey series. Well, you don't have to discuss about Humphrey, leave it. You have to discuss all this. Now, the first question that will be asked. The first question that will be asked. What is that? What is that? Lyman series comes in which region? Ultraviolet, visible, infrared, which one? Remember, ultraviolet, this Lyman, it comes in UV region. This can be the question asked. Balmer comes in visible. It comes in visible, right? Paschen, infrared. Infrared. Bracket, infrared. Fund, infrared. In the NEET 2022 or 2021, the question was asked, in which region comes your Balmer series? It comes in visible spectrum. It comes in visible spectrum. Okay, this is the first question which can be asked here. The second question, my dear students, which can be asked. What is that? Understand properly what I'm going to say. First of all, this is your Lyman series, and this particular line is called as H alpha line of Lyman series, or you can call it as the first line of Lyman series. This is called as H beta line of Lyman series. H beta, or you can call it as second line of Lyman series. H gamma, or third line of Lyman series. Fourth line of Lyman series. Fifth line of Lyman series. Right? Remember the terminologies. Similarly, this is called as first line of Balmer, second line of Balmer, third line of Balmer, first line of Paschen, second line of Paschen, third line, first line of bracket, second line of bracket, third line, etc., etc. Okay? Perfect. Now, people, the second question that will be asked, what is that? Since we know when the electron makes a transition from higher energy state to lower energy state, from higher energy state to lower, it emits energy in the form of radiation. When the electron makes a transition from higher energy state to lower energy state, it emits energy in the form of radiation. That radiation would be definitely having some wavelength. We will have to calculate that wavelength. We will have to calculate that wavelength. So mark the heading as calculation of lambda. Calculation of wavelength. And wavelength, when the electron makes a transition from higher energy state to lower energy state, it emits energy in the form of radiation. That radiation has got the wavelength as well. That radiation has got the wavelength as well. How do we calculate that wavelength? With the help of a formula called as the Rydberg's formula. Called as the Rydberg's formula. And what is this Rydberg's formula? What is this Rydberg's formula? Simple. Wave number, which is basically your 1 by lambda is called as wave number, is equal to R Z square 1 upon N1 square minus 1 upon N2 square. Now, you must be thinking, what is this R, what is this N1, what is this N2, etc., etc. Let me tell you, N1 is the lower energy state in which the electron will be. N2 is the higher energy state in which the electron will be. And remember, this R is the Rydberg's constant. You don't have to remember the value of Rydberg's constant. You have to remember the value of 1 by r. Remember 1 by r value is 911.5 angstroms. 911.5 angstroms. Okay. Now the point is, how do I use this formula? How do I use this formula? Before telling you that, how do I use this formula? Do you know your delta E is equal to hc by lambda, or I'll say your delta E is inversely proportional to lambda. Your delta E is inversely proportional to lambda. So more the energy gap between the two shells, lesser will be the wavelength of the radiation emitted. Right? More the energy gap between the two shells, lesser is the wavelength of the radiation emitted. Lesser the energy gap between the two shells, more will be the wavelength of the radiation emitted. Yeah? Do you know that? Now try to understand. The first question which will be asked, what is that? Let me first of all talk about Lyman series. These are all the questions which I'm going to give you. Let me talk about the Lyman series. For example, they'll ask you, calculate the series limit. Calculate the series limit in Lyman series. Series limit means the shortest wavelength. Series limit means the shortest wavelength emitted in Lyman series. Now you tell me, when can be the wavelength shortest? Wavelength will be shortest when energy gap is maximum. Now in Lyman, when is the energy gap maximum? Where is the energy gap maximum? In Lyman, the energy gap is maximum when the electron makes a transition from infinity to 1. When the electron makes a transition from infinity to 1. So the electron is making a transition from infinity to 1. Lower energy state I represent with N1. Higher energy state I represent with N2. Correct? Now, calculate the wavelength emitted. Formula. 1 divided by lambda is equal to R. Z for hydrogen is 1. Right? 1 upon N1 square, which is 1. Minus 1 upon N2 square. Infinity ka square is infinity only. 1 by infinity is 0. So 1 divided by lambda minimum is equal to R. Simple. Or if I take the reciprocal, I can say lambda minimum is equal to 1 by R, and 1 by R is nothing but 911.5 angstrom. So this is the answer of the question. Done. This is the answer of the question. The second question which they can ask you directly here, calculate the longest wavelength in Lyman. Calculate the longest wavelength in Lyman. Lambda maximum in Lyman. Tell me, when would be the wavelength maximum? You tell me. This would be maximum when energy gap is minimum. Now, in Lyman, where is the energy gap minimum? Energy gap is minimum when the electron makes a transition from 2 to 1. Right? When the electron makes a transition from 2 to 1. So the transition has to be from 2 to 1. This lower energy state is represented by N1, higher energy state represented by N2. Now, 1 divided by lambda max is equal to R, Z square, Z is 1. 1 upon N1 ka square, minus 1 upon N2 square, 2 ka square is 4. So this is 1 divided by lambda max is equal to R. 4 minus 1 is 3, so it's 3 divided by 4. Take the reciprocal. If I take the reciprocal, so lambda max is equal to 4 divided by 3 into 1 by R. So it's going to be 4 by 3 and 1 by R value. Again, I gave you already, that's 911.5. Solve this, get the answer. That's it. Okay, what if they ask you, calculate the series limit in Balmer? Series limit. Series limit means shortest wavelength. Shortest wavelength in Balmer. Wavelength will be shortest when delta is maximum. Now in Balmer, when is delta E maximum? When the electron makes a transition from infinity to 2. So you have to take the transition from infinity to 2. You have to take the transition from infinity to 2. Calculate the longest wavelength in Balmer. Longest wavelength in Balmer. Longest wavelength in Balmer. Wavelength will be longest when delta is minimum. Delta is minimum in Balmer. Delta E minimum in Balmer. That means when the electron makes a transition from 3 to 2. Understood? So all this will be asked. There will be one more sub-concept that will be asked here. What is that sub-concept? That is calculation of total spectral lines. Or let me write, calculation of maximum spectral lines. Calculation of maximum spectral lines. For example, they'll give you a question. The electron is making a transition from 6 to 1. The electron has to go from 6 to 1. How many maximum spectral lines can be obtained? How many maximum spectral lines can be obtained? There is one formula for that. Remember, it is N2 minus N1. This is N2 minus N1 plus 1 divided by 2. Okay, and this formula is valid for large number of atoms. You don't have to take the value of R. You have to take the value of 1 by R. 1 by R is 911.5. See guys, what I'm trying to say. Understand probably what I'm trying to say. I'm telling you, for example, the electron is making a transition from 10 to 1. How many maximum spectral lines can be obtained? The formula is n2 minus n1 into n2 minus n1 plus 1 divided by 2. Okay. One more thing. Before showing you the question on this, one more thing. Now, out of the maximum spectral lines obtained, how many spectral lines will fall into Lyman? How many spectral lines will fall into Balmer? How many spectral lines will fall into Paschen? So remember, spectral lines falling in a region, in a particular series. That is given by N2, which is higher energy state, minus ground state of that series. What is meant by all this? Let me tell you that. First of all, remember these two formulas. Direct questions have been asked from these two formulas. So let me show you what kind of questions can be asked. For example, the question is, the electron is making a electron has to come from 6 to 1. Okay? Electron has to come from 6 to 1. First of all, this is your lower energy state, which we represent with N1, higher energy state, which we represent with N2. Calculate the total spectral lines. Total spectral lines is equal to N2 minus N1, N2 minus N1 plus 1 divided by 2. So this will be 1 cancel, 6 5s are 30, 30 divided by 2 is 15. So total spectral lines obtained is 15. Now out of these 15 spectral lines, how many will fall into Lyman? How many in Balmer? So remember, out of these 15, how many spectral lines will fall into Lyman? That is N2. N2 is the higher energy state, which is 6 minus. Just give me a second. Did I write the formula correct? 5 into 6 is 30 divided by 2. Okay. How many will fall into Lyman? N2. N2 is 6 minus ground state of Lyman. Minus ground state of Lyman. What is the ground state of Lyman? That's 1. So this is 5. Okay. How many will fall into Balmer? Out of these 15, how many will fall into Balmer? N2 minus ground state of Balmer. That's 2. 6 minus 2 is 4. How many will fall into Paschen? N2, which is the higher energy state, minus ground state of Paschen. That is 3. So 6 minus 3 is 3. Bracket will be 6 minus 4, that's 2. Fund. 6 minus 5, that is 1. So if you add all of this, 5 plus 4 plus 3 plus 2 plus 1, it will come out to be 15 only. Understood, people? Understood? Anything can be asked from this. For example. First of all, these 3 questions you can do on your own. Easy. Easy questions. Calculate lambda infinite in Balmer. Lambda infinite in Balmer means when the electron makes a transition from infinity to what is the ground state of Balmer? 2. So you have to take the transition from infinity to 2. Okay. Series limit of Lyman, we have already calculated. H beta line. H beta line means second line of Paschen. Lyman, Balmer, Paschen. Ground state is 3. Now H beta line. H alpha will be 4 to 3. H beta will be 5 to 3. So you have to take the transition from 5 to 3. These sort of questions, I mean, you should be in a position to do. Now, you just tell me one thing. Can we solve this question? Can we solve this question? Can we solve this question? Check it out. The question is, hydrogen atom in the ground state is excited by a monochromatic radiation of the wavelength lambda. Oh my God. On coming back to the ground state, 15 spectral lines are obtained. First of all, let's say hydrogen electron is excited to some higher energy state, that's N2. Then it's from N2, it's again coming to the ground state. Ground state means first, right? So electron is making a transition from N2 to N1. So when the electron will be making a transition from N2 to N1, higher energy state to lower energy state, how many total spectral lines are obtained? 15. How many total spectral lines are obtained? 15. So total spectral lines, 15 is equal to N2 minus N1 multiplied by N2 minus N1 plus 1 divided by 2. right? So this got cancelled. So 15 to it is 30 is equal to, this is n2 and this is n2 minus n1. Sorry, n2 minus 1. Now what will be the value of n2 here? This has to be 6. If this is 6, 6 minus 1 will be 5. So 6 5s are 30. So n2 value has to be 6. Then only this equation is satisfied. So technically I would say electron is making a transition from 6 to 1. We got to know electron is making a transition from 6 to 1. And calculate lambda. When electron makes a transition from 6 to 1, how do we calculate lambda? Rydberg's formula. What is Rydberg's formula? 1 by lambda is equal to R, Z for hydrogen is 1, 1 upon n1 square minus 1 upon n2. n2, 6 ka square is 36. n2 square. So it's 1 by lambda is equal to R. 36 minus 1 is 35 divided by 36. Take the reciprocal. So lambda is equal to 36 divided by 35 into 1 by R. 1 by R is 911.5. Solve this, get the answer. You're done. Yes? Salt analysis is important and easy. You can easily score 2 questions from that. So do not miss that. Do not miss that. Soon I'll take 1 session on that as well. Don't worry. Can you check this question out? Can you check this question out? Check this question out. Electron in the hydrogen atom jumps from some higher energy level, let that be N2, to third energy level. To third energy level. If 6 spectral lines are possible for the transition, find the initial position. So total spectral line 6. So total spectral lines is equal to N2 minus N1 multiplied by N2 minus N1 plus 1 divided by 2. Solve the equation, get the value of N2. That's it. Right? Right, people? Sir, you don't complete any series. My dear student, go to the playlist. All the syllabus is there in the playlist. Check it out. Entire syllabus of PCB is there in the playlist. Okay? So do not say something like that. You have entire syllabus in the playlist. Go to the playlist. Every chapter of mine, Yavar sir, Ambika ma'am, even KK sir has completed his organic portion as well. You will get every single chapter. Whatever chapter you want, everything is there. Now, there will be some chapters that were done in 2025. You can consult them today also. Some chapters that were done in 2026. You can consult them today also. Okay? Right? Chalo, I hope this is done. Now, can you solve this question on your own? What do you think? What do you think about this? Tell me, can you solve this question now? I mean, you should be in a position to solve it, guys. What are you doing? Tell me. Quick. Quick. I know you are going to make one mistake here in this question. See, in hydrogen atom, electron makes a transition from fourth excited state. Fourth excited state means N is equal to 5. Fourth excited state. To second state. Fourth excited state to second energy state. These are two different things. Fourth excited state means N is equal to 5. Second energy state is 2, direct. Okay? Do you understand what I'm trying to say? This is where you can commit a mistake. Now, everything is in front of you. Total spectral lines is equal to N2 minus N1, N2 minus N1 plus 1 divided by 2. So 5 minus 1 is 4. 5 minus 2 is 3. 3 plus 1 is 4 divided by 2. So the value comes out to be 8. Is that? I think I did something wrong. N2 minus N1. I took wrong values, I think. Yeah, I took wrong values. N2 minus N1. N2 is 5. N1 is 2. N2 minus N1. N2 minus N1 plus 1 divided by 2. Now correct. 5 minus 2 is 3. Right? 5 minus is 3. 3 plus 1 is 4 divided by 2. So total spectral line 6. Total spectral line 6. Total spectral line 6. Now we have to check. Out of 6, which one will be falling in Lyman? N2. N2 is 5 minus ground state of Lyman is 1. So 4. Balmer. N2, that's 5 minus ground state of Balmer is 2. That's 3. Paschen. N2 is 5. Ground state of Paschen. Lyman-Balmer Paschen is 3. So 2. Bracket. N2 minus 4. That's 1. Now you can check. 10 different spectral lines? No. Number of lines belonging to Balmer. Balmer is 3. So this is correct. Number of lines belonging to Paschen. Paschen is 2. This is correct. So BCD is correct. Okay, BCD is correct here in this particular scenario. I believe I'm clear to you. I believe I'm clear to you. So how many concepts are done so far? How many concepts are done so far? Tell me that. Tell me that. Tell me that. Seven concepts, right? The 8th concept is basically from your chemical bonding. The 8th concept is basically from your chemical bonding. Fajan's rules. Fajan's rules. Now guys, in short, I'll be just telling you those things which are required to solve the question. Nothing more, nothing less. Okay? I'm not going into very depth and all, right? Perfect. Because in depth, I have taught the same chemical bonding on the same channel for 12 hours. You can check that too if you would want to learn the concepts in very detailed format. But that time is gone for you. Okay? Just remember those things which are required to crack a question. That's it. Okay? Fajan's rules. First of all, Fajan's rules is going to give us, it is going to let us know, it is going to help us in comparing covalent character in ionic bonds. Covalent character in ionic bonds. With the help of Fajan's rules, what do we compare? We compare covalent character in ionic bonds. Covalent character in ionic compounds, I mean. Now try to understand. Just remember two things. Just remember two things for now. See how can you easily solve the questions. First of all, covalent character in an ionic bond. Covalent character in an ionic bond is directly proportional to what? Covalent character in an ionic bond is directly proportional to polarizing power. Polarizing power of what? Of cation. Polarizing power is defined for cation. First, take down these things. I'll make you understand in some time, okay? Similarly, this covalent character in an ionic bond is directly proportional to there is a term called as polarizability. Polarizability is defined for anion. Polarizability is defined for anion. The third thing which you have to remember, polarizing power of cation is directly proportional to the charge of the cation and inversely proportional to the size of the cation. And similarly, polarizability is defined for anions. Polarizability of anion is directly proportional to the charge of anion as well as directly proportional to the size of anion. If you just remember this slide, you can easily solve the questions. If you just remember these concepts, these things, you can solve the questions easily. First of all, see, covalent character, directly proportional to polarizing power of cation, directly proportional to polarizability of anion. Polarizing power of cation is directly proportional to charge on cation, inversely proportional to size. Polarizability of anion, directly proportional to charge on anion, directly proportional to size of anion. Simple. Simple. Okay? Now, guys, one more thing which I would want you guys to remember. What is that? What is that? If the cation belongs to 3D series, the cation can belong to 4D also. It can belong to 5D also. Right? Remember this. From 3D to 4D, 4D to 5D, Z effective increases. Effective nuclear charge increases. Or in short, remember, polarizing power increases. Just remember this point. In the 3D series, from 3D to 4D, 4D to 5D, remember, polarizing power of the cation increases. For example, have a look what I'm trying to say. Arrange the following on the base of their covalent character. Arrange the following on the base of their covalent character. See what I'll be doing. First of all, this is your zinc dye positive. This is Cl negative. Cadmium dye positive, Cl negative. Hg dye positive, Cl negative. See, Cl negative is same everywhere. So you cannot decide on the basis of Cl negative. So talk in terms of cations. This is your 3D element. This is 4D element. This is 5D element. Now 3D, 4D, 5D. Which one has got more polarizing power? 5D. More the polarizing power. More the polarizing power of the cation. More is the covalent character. Simple. So this is the order of covalent character. If they ask you about the order of ionic character, just reverse the symbols. Ionic character order will be like this. This will be order of ionic character. Okay, this will be order of the ionic character. Perfect. Similarly, this is zinc dye positive, S dye negative, cadmium dye positive, S dye negative, Hg dye positive, S dye negative. S dye negative everywhere same. This is 3D element. This is 4D. This is 5D. Right? So, which will have more polarizing power? This one. More polarizing power means more polarizing power means more polarizing power of cation means more covalent character, right? Now, this is Li positive, F negative, Na positive, F negative, K positive, F negative, Rb positive, F negative, Cs positive, F negative. F negative everywhere same. Now, the charge on cation also is same. Charge on cation also is same. So you cannot decide on the basis of charge. You cannot decide on the basis of charge of cation. Now, you have to decide from the size of cation. Li positive, Na positive, K positive, Rb positive, Cesium, lithium, sodium, potassium, rubidium, cesium. Down the group size increase. Down the group size increases. Down the group size increases. So this will be having maximum size. Cs positive will be having maximum size. Maximum size means less polarizing power because inversely proportional. Less polarizing power means less covalent character. So this is the order of covalent character. Right? This is BeF2. This is BeCl2. Dye positive F negative. Dye positive Cl negative. Dye positive Br negative. Dye positive this. So B dye positive everywhere same. Now talk in terms of anion. The charge on anion is everywhere same. Now talk in terms of size. Chlorine, chlorine, bromine, iodine. Down the group size increases. Down the group size increase. Size of I negative will be maximum. More the size of anion, more the polarizability of anion. And more polarizability of anion means more the covalent character. Done? Tell me the answer of these. This is your Al tripositive. See, Al tripositive is everywhere. So I cannot decide on the basis of Al tripositive. Now, F negative, Cl negative, Br negative, I negative. I negative has got maximum size. More the size of anion, more the polarizability, more the covalent character. Done and dusted. More the size of anion, more the polarizability. So everywhere, more the size of anion, more the polarizability, more the covalent character. Okay. Now, among CuCl and Na, can you tell me which one is more covalent? Can you tell me? This is the special case. This is Cu positive, this is Cl negative. This is Na positive, this is Cl negative. Okay? Remember one thing, guys. Remember. If I see, you cannot decide on the basis of Cl negative. You have to decide on the basis of Cu positive. and Na positive. If I ask you, what is the electronic configuration of your Cu positive? Cu positive configuration is argon with 3d10 configuration. What is the electronic configuration of Na positive? It is simple. Neon. 3s0, because one electron has taken out. This is their electronic configuration. Whenever you see this kind of the configuration, that is, whenever you see this kind of the configuration, that means noble gas followed by D10 configuration. Noble gas followed by D10 configuration. You call this configuration as the pseudo inert gas configuration. You call this as the pseudo inert gas configuration. This is just called as inert gas configuration. This is just called as the inert gas configuration. Remember that cation with pseudo inert gas configuration. What is pseudo inert gas configuration? What is pseudo inert gas? You know, it is noble gas configuration followed by D10. Noble gas configuration followed by D10. So this is pseudo inert gas. This is inert gas configuration. That cation which shows pseudo inert gas configuration, its polarizing power will be more. So this cation will have more polarizing power. More the polarizing power of cation, more is the covalent character. As simple as that. Got it? Am I clear, guys? Am I clear? How many concepts discussed till now? 9. Okay, 9. Talk about the 10th one. Concept number 10. Sorry. Are we done with 8 concepts or 9 concepts? I think we are done with 8 concepts. Okay. Concept number 9, guys. Concept number 9. That is, how do we check hybridization? How do we calculate hybridization? How do we calculate hybridization? Yeah? How do we calculate hybridization? Just, it will take 15 minutes to make your hybridization done and dusted. See, guys. First of all, in order to calculate the hybridization, there is a method called as steric number. Steric number method. Steric number is nothing but it is number of sigma bonds which the central atom forms. The number of sigma bonds which the central atom forms plus the number of lone pairs on the central atom. Plus the number of lone pairs on the central atom. Steric number is equal to sigma plus lone pair. Now, the first point which you have to remember a few things for now. I'll make you understand these things one by one. Remember, if the steric number comes out to be 2, if the steric number comes out to be, how it will come out to be 2, that I'll show you. But remember for now, if the steric number comes out to be 2, hybridization involved is going to be SP. And geometry predicted through hybridization, that is linear. Geometry predicted through hybridization, that's called as linear. Linear geometry. Linear geometry. SP. Okay. If the steric number comes out to be 3, hybridization is going to be SP2. Geometry involved is going to be trigonal planar. Trigonal planar. Steric number 4, hybridization involved, SP3. Geometry as per hybridization, tetrahedral. Tetrahedral. Steric number 5, SP3D. Trigonal bipyramidal. Trigonal bipyramidal. Steric number 6, SP3D2. Geometry octahedral. Steric number 7, SP3D3. Pentagonal bipyramidal. Pentagonal bipyramidal. Now, one more thing which can be asked. What is that? See. I'll start from here, sp3. In case of sp3 hybridization, which orbitals have participated in hybridization? It is s and 3p orbitals. So it's going to be s plus px plus py plus pz. These are the 4 atomic orbitals which would have participated in the hybridization. sp3d. How many? Which all orbitals have participated? S, 3p and 1d. Now, s plus px plus py plus pz, and which d orbital is involved here? It is dz square that's involved. dz square that's involved. sp3d2, s, px, py, pz, dx square minus y square, dz square. These are the orbitals involved in the hybridization in case of sp3d2. Similarly, sp3d3, s, this is px, this is py, this is pz, dz square, dx square minus y square, and dxy. These are the orbitals which are involved in the hybridization. Now the point is, how do we calculate this hybridization? How do we calculate this hybridization? Now try to understand very carefully what I'll be doing. Very carefully. One by one, I'll show you a lot of examples. With that, things will be very clear to you. For example, example number 1. Let's say I'm starting with the simplest one, that is CH4. I need to check the hybridization of carbon. I need to check the hybridization of carbon, right? I need to check the hybridization of carbon. My dear students, if you look carefully, this carbon is your central atom. It is your central atom, okay? Now, how many valence electrons this central atom has? I would say carbon has got 4 valence electrons. You should know it. How many surrounding atoms do you see here? 4. You see 4 surrounding atoms. Remember, number of surrounding atoms is equal to number of sigma bonds. Number of surrounding atoms is equal to number of sigma bonds. Number of surrounding atoms is equal to number of sigma bonds. Now, 4 valence electrons carbon had. 4 sigma bonds carbon is forming. 4 valence electrons carbon had. 4 sigma bonds it's forming. Right? That means carbon has utilized all its 4 electrons to form 4 sigma bonds. So there will be no lone pair on carbon. So sigma 4 lone pair 0. Steric number is equal sigma plus lone pair. When steric number is 4, hybridization involved is sp3. Done? And remember, in sp3, the bond angle is 109 degree 28 minutes. Okay? You can remember here also. Here the bond angle is 180 degree. Here the bond angle is 120. And here the bond angle is, as I told you, it is 109 degree 28 minutes. Okay? Here you have to check whether we are talking about axial, equatorial, 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 axial, axial, and so on. Okay. Let me give you one more example. For example, talk about NH3. Talk about NH3. Tell me which one is the central atom? Nitrogen. How many valence electrons are there with nitrogen? 5. Right? 5. How many surrounding atoms are there? How many surrounding atoms are there? Just tell me that at least. Quick in the chats, quick in the chats. Quick in the chats. How many surrounding atoms are there? There are 3 surrounding atoms. So sigma bonds are 3. So 5 valence electrons, 3 sigma bonds. So out of 5 valence electrons, 3 are utilized and form 3 sigma bonds. So there'll be 2 valence electrons left on nitrogen in the form of a lone pair. So 1 lone pair. Sigma 3, lone pair 1. Steric number will be 3 plus 1, 4. Steric number 4 means hybridization again is sp3. sp3. Simple. For example, you have got H2O. Oxygen is the central atom. How many valence electrons oxygen has? Oxygen has got 6 valence electrons. Right? How many surrounding atoms? 2. Out of 6 valence electrons, oxygen has utilized 2 of its valence electrons to form 2 sigma bonds. So 4 valence electrons are left as such in the form of 2 lone pairs. Steric number, 2 plus 2, 4. 2 plus 2, 4. Hybridization, sp3. For example, you have got I3 negative. We have to check the hybridization of iodine. How do I do that? I3 negative I can write as I2 negative. I2 negative. Right? Call this iodine as the central atom. How many valence electron iodine has? 7. But there is a negative charge here. So add this negative charge. There's a negative charge. So add it. If there was positive, subtract it. Right? Okay? Okay, so valence electrons are 8. How many surrounding atoms? 2. So sigma bonds are 2. So out of 8 valence electrons, 2 are used. So 6 are left in the form of 3 lone pairs. So lone pairs are 3. Steric number 3 plus 2, 5. If steric number is 5, hybridization involved is sp3d. Do you see? Do you see this? For example, XeF2, hybridization of xenon. First of all, if I talk about a hybridization of xenon, xenon has 8 valence electrons. It belongs to group 18. 8 valence electrons. How many surrounding atoms? 2. So sigma bonds 2. How many lone pairs? Out of 8, 2 are used. So 6 are left as such in the form of 3 lone pairs. So steric number 3 plus 2, 5. Hybridization sp3d. Simple. Right? For example, you have got NO2 negative. Now, nitrogen. How many valence electrons? 5. So there is a negative charge, so add it. 5 plus 1, 6. How many surrounding atoms? 2 surrounding atoms means 2 sigma bonds. Right? But when oxygen is the surrounding atom, how do I check lone pair at that time? When oxygen is the surrounding atom, how do I check the lone pair? How do I check the lone pair? How do I check the lone pair? It's going to be valence electrons minus 2 into sigma bonds. Valence electrons minus 2 into sigma bonds divided by 2. Valence electrons are 6 minus 2 into sigma divided by 2. So 6 minus 4 is 2, 2 by 2 is 1. So there is one lone pair on nitrogen. So sigma 2, one lone pair, right? So steric number 3 plus 2 plus 1, 3. Hybridization sp2. Perfect. Right? Got it? For example, you have got NO2 positive. NO2 positive, nitrogen. Valence electrons, 5. Sigma bonds, 2. Lone pair. Since oxygen is a surrounding atom, so how do I calculate the lone pairs? Valence electrons, which are 5. Sorry, not 5, there is a positive charge as well. So 5 minus 1 is 4. 5 minus 1 is 4. So lone pairs will be valence electrons, which are 4 minus 2 into sigma divided by 2. So it will be 4 minus 4, 0. So lone pair 0. So sigma 2, lone pair 0. Steric number is equal to 2 plus 0, 2. Hybridization will be sp. Right? Perfect. Am I clear? Am I clear, guys? Okay. All right. Concept number 10, which is the last concept of the today's session. What is that? That is, questions are based on bond order calculation. Bond order. I'm going to give you one trick. You all must have seen that short video also of mine. Right? With the help of short video also, you can cover that. See. And at the end, I have to, after this particular one, I have to tell you one important thing, okay? Just wait. Okay, bond order. First of all, bond order is directly proportional to bond strength. Bond order represents basically number of bonds between two atoms. More the bonds, more the bond strength. Right? सर आपके बताए हुए कॉन्सेप्ट्स पक्का नीट पेपर में आएंगे ना? यार मैंने ये वीडियो YouTube पे डाला है, मतलब पूरी कंट्री इस वीडियो को देख चुकी है, ठीक है? तो इतना मैं दिमाग से पैदल तो हूं नहीं ना, ऐसे में नेशनल प्लेटफॉर्म पे कोई वीडियो डाल दूं। तो मुझे भी पता है ना, अगर इनमें से कोई कॉन्सेप्ट कल एग्जाम में नहीं आएगा तो मेरी तो धज्जियां उड़ जाएंगी YouTube पे ही, राइट? बट आई एम confident enough, I know paper will come from these topics only. That's the reason I posted that video. So use your brain a bit. Okay? All right? Chalo. First of all, bond order is directly proportional to what? Bond order is directly proportional to bond strength. And remember, bond strength is inversely proportional to bond length. Bond length. Right? Or you can say, bond order is directly proportional to bond dissociation energy as well. Bond dissociation energy as well. Okay? Right? Just a second, guys. Okay. Now you just have to remember one simple trick. Whenever you see a 14 electron species, its bond order is going to be 3. 15 electron species, its bond order will be 2.5. 16 electron species, bond order 2. 17 electron species, bond order 1.5. 18 electron species, bond order 1. 13 electron species, bond order 2.5. 12 electron species, bond order 2. 11 electron species, bond order 1.5. 10 electron species, bond order 1. So basically, you have to consider this as the reference. You have to take this as the reference. When you go beyond this, subtract by 0.5, 0.5, 0.5. When you go beyond this, subtract by 0.5, 0.5, 0.5. Okay? For example, if I talk about nitrogen, N2 molecule, in one nitrogen atom, one nitrogen atom, how many electrons will be there? 7. Nitrogen has got the atomic number of 7, so there are 7 electrons. So in N2, there are 14 electrons. So N2 is a 14 electron species. N2 is a 14 electron species. Its bond order will be 3, right? For example, you have got CO, carbon monoxide, CO. Oxygen, atomic number 8, atomic number 6, so 8 plus 6, 14. Again, this is a 14 electron species. Its bond order will be also 3. And those species which have got same number of electrons, you call these species as isoelectronic species. So remember, isoelectronic species will also have the same bond order. Isoelectronic species will have the same bond order, right? There is one exception, remember. In CO positive, how many total electrons are there? 8 plus 6 is 14, 14 minus 1 is 13. So it is a 13 electron species. So if it is a 13 electron species, its bond order was supposed to be 2.5. But remember, its bond order is 3.5. In CO positive, bond order is 3.5. Okay? Bond order is 3.5. Now people, one more thing. For example, there is a question. Questions can be asked in different formats. For example, they give a question. Tell me, O2 positive, O2 negative. Give the bond order over here. Which one has got more bond order, which one has got lesser? Check the number of electrons. O2, 8 is 16 electron species. 16 minus 1. There's a positive charge. 16, this is a 15 electron species. So 8, 16. 16 plus 1. 17 electron species. Right? 16 electron species will have a bond order of 2. Right? 15 electron species will have a bond order of 2.5. 17 electron species will have the bond order of 1.5. So this is your order of the BO, bond order. Now, give the order of the bond length. Give the order of the bond length. So inverse of this, right? You have the bond order. Now, you know that more the bond order, less the bond length, right? Less the bond length. Perfect. So you can give the order as per bond order. You can give the order as per the bond length. You can give the order as per bond strength, as per the bond dissociation energy, right? Similarly, there is one more set of questions asked. You'll be given with pair of molecules. In option number A, 2 pair of molecules. In option number B, 2 pair of molecules. In option number C, 2 pair of molecules. Now they will ask you in which pair the bond order is same. You just have to see in which pair you find isoelectronic species. Isoelectronic species will have same bond order. That's all. Same bond order. That's all. Right? And remember one more thing. There is a molecule C2. C2 is a 12 electron species. Its bond order is 2. So that means there should be a double bond like this. And remember, in C2 molecule, both the bonds are pi bonds. In C2 molecule, both the bonds are pi bonds. Otherwise, normally what happens? First sigma gets formed, then pi. But in C2, both are pi bonds. This can also be asked in your examination. Perfect? Perfect, guys? So these were the 10 concepts that I discussed in the today's session. My dear students, let me show you again what is our schedule. So today, this session is done. Tomorrow, 10 concepts at 9 PM with KK sir. Day after tomorrow, Friday, with me again, 10 concepts. Sunday, with KK sir. Tuesday, with me, 10 more concepts. So in 50 to 60 concepts, you should be getting your entire chemistry paper for sure, right? And one thing which I would want from all of you. First of all, the PDF of this session I'll be sharing in this Telegram. PDF of this session is something I'll be sharing in this particular Telegram. Number one. Number two, when I end the session, you will have to tell me in the comments, right? How did you like the session? Okay? You'll have to tell me in the comments, how did you like the session? Not in the chats, in the comments. But I want comments from everyone, okay? So that I'll get to know whether you got benefited out of this session or not. Okay, one more thing, people. When I open this channel, when I open this particular channel, and the ones who have not liked this session, do like this session right now, okay? I'll kill you. Okay, click on the live category. When I go to the live category, already there is one more session scheduled. Okay, one more session scheduled. This is the session which I'll be taking on 3rd April. That means day after tomorrow. The ones who have not smashed the like yet, do smash the like, mark your attendance so that I'll get to know how many people are actually serious about this particular session as well. So these are all the things which I want you guys to do. First of all, do comment on the video. Tell me how did you like the session. Number 2, do smash the like session for this one as well so that I'll get to know whether people are serious about the second session. Otherwise, I would have to, if I did not get enough likes, that means a lot of students are not serious about this session. So maybe I'll have to cancel this. If you want me to do that, then the choice is all yours. Yeah? Yeah? Chalo, I'm going to take a leave with this. I'll see you guys day after tomorrow. Till then, you take care. God bless you all. Love you all. And one thing I'm telling you, your entire chemistry paper will come from these topics only. It's my promise to you.